Okay, today we're going to look at two things that, kind of three, that go along with the fundamental theorem of calculus. The first one is called the second fundamental theorem of calculus. And this one is definitely not as important as the one that we talked about in the previous lesson, but it's something you should know. And here's what it looks like, and if you get through all the symbols, it's not that hard. Basically, it says if you take the derivative with respect to x of an integral evaluated from some constant a to x of f of t dt. So let's just talk about what that says. I'm going to integrate with a variable other than x, so t, and then I'm going to substitute x in because that's my upper boundary, and then I'm going to take the derivative of that answer. That leaves me with this function, whatever it is, in terms of x. So let me show you how that works. Basically, if I tell you that f of x equals 0 to x, so the integral between 0 and x of t times t squared plus 1 dt. Well, because of the second fundamental theorem of calculus, I know right away that this is just x times x squared plus 1. Or I guess I could write that as x cubed plus x, however you want to write that. I know the second fundamental theorem guarantees that because that's what it says. Basically, it says if you're going to take the derivative of this. If you take the derivative of an antiderivative and you switch your variables, you get this original function in terms of x. So let me show you why that works real quick. All right, so let's pretend I didn't know this was the answer, or I'm taking my test next week and I don't remember the second fundamental theorem of calculus, so here's what I do. I still integrate. So I'm going to rewrite this, 0 to x. Well, if I was going to integrate this, I would change it to t cubed plus t dt. And then I integrate. Oops, I'm going to scroll back up here. So when I integrate, I get t to the fourth over 4 plus t squared over 2, and I'm going to integrate between 0 and x because that's my lower and upper boundary. So I get x to the fourth over 4 plus x squared over 2 for my first term minus, well, when I put in 0, I just get 0. So I have x to the fourth over 4 plus x squared over 2, and then it was minus 0. Now, according to the second fundamental theorem of calculus, I'm supposed to take the derivative of this. And when I take the derivative of this, I end up getting x cubed plus x, what I was supposed to get. Now, why is this used? Well, it's used lots of ways. You're going to see it in Calc 2 again, and it's just one of those theorems that we like you to know that you can just make it a shortcut. Okay, so the shortcut is I don't really have to do all this work when they ask me about using this capital F for the antiderivative and finding lower f, which is the function, right? The original function there. I can just plug in x and have my answer. The only problem is sometimes, like that one's fairly easy. So like I'll show you another easy one real fast. If I go 0 to x of t to the fourth dt, and I'm looking to figure out what that is in terms of x. So I want to figure out that function in terms of x, and I want to find little f of x. All that's going to be is x to the fourth. I just have to substitute x in here. Now the only problem that happens with this is, let's say I'm going to do 0 to x cubed of t to the fourth dt. What happens is everybody's like, oh, this is easy. I just know that my smaller function of f of x here is going to be x cubed, right? Because I'm going to substitute that in, raised to the fourth, which is x to the 12th. That's not right. That is not right. Because what you have here is, think about it, you're taking a derivative. And so I actually have to multiply this x to the 12th times the derivative of what I'm substituting in. The derivative of that would be 3x squared. So I actually get 3x to the 14th. And let me show you how that one works really quick. So I'm going 0 to x cubed of t to the 4th dt. We'll integrate, because that's what it says to do. So that gives me t to the 5th over 5. And I'm going to go between 0 and x cubed. So I put x cubed in here, and I get x cubed to the 5th over 5. I put 0 in there, I get 0. The derivative of that's 0, so I'm not going to worry about that. So I'm going to simplify. I'm going to simplify this, and I get x to the 15th over 5. And now what the second fundamental theorem says is I have to take the derivative of that. Well, the derivative of that would be 15x to the 14th over 5, which is 3x to the 14th. So that's the second fundamental theorem of calculus. Now the next thing that you need to look at, actually I'm going to just put it in its own video